In this video, I'm going to review how to graph an exponential and then determine if it's a growth or decay. But then I also want to be able to identify four main key features. So for this first one, if I look at our base right here is 1/3. So if our base is 1/3, that is a clue that tells us this is a decay, which means it's going to go down from left to right. But I need to graph some points. Now you can choose any x values to put into our exponents, into our function. I typically, if I'm only doing 3 points, I typically use -1, 0, and 1. But again, you can choose any numbers you want to put in there. So if I put a -1 in for x, anytime I have a negative exponent, I have to do the reciprocal of the base. So 1/3 to the -1st power means I have to do the reciprocal of 1/3. And the reciprocal of 1/3 is 3. So 1/3 to the -1st power is 3. 3 to the 1st power now is 3. 3 times 2 is 6. So I'm going to come to my graph. I'm going to put a point at -1, 6. Now I'm going to put a 0 in for x. And anytime I have a 0 as an exponent, my answer would be a 1. So 1/3 to the 0 power is 1. And then I have 1 times 2 is 2. So I have a point at 0, 2. So I'm going to put a point there. Then if I put a 1 in for x, 1/3 to the 1st power, anything to the 1st power is itself. So that's 1/3. 1/3 times 2 is 2/3. So 1 and 2/3 would be roughly somewhere around here. Now there's one thing I need to put in there, and that's my asymptote. So exponentials, we have an asymptote, a boundary line. So for exponentials, our y can never equal 0 because I can't put anything to a power to make it equal 0. So I'm going to put my asymptote as a thick yellow line here. Now normally you would put it as a dashed line, but just to make it easier for you to see, that yellow highlighted part, that's going to be our asymptote. So it never touches it. It approaches it, but never touches it. So now I can draw my graph here. I'm going to use a different color. So let's use green. So that means it gets close to the x-axis, but never touches it. It comes up. And then it's just going to keep going this direction. Now I continued it up in a general form of where it would go. If I plot more points, it'd be a little more accurate, but you can see that it keeps going up and to the left. Now the key features, and this part is important for you to be able to identify the key features. So we want to do the domain first. I'm going to get a ruler out here. So with this ruler, I need to make this go across the x-axis, and when it's crossing the x-axis, I want to see, does it touch the green line? Yes, it keeps touching the green line here all the way through, which means there's no limitations. So for a basic exponential function, whether it's a growth or a decay, I can put any x in here and it will give me a y value that lands on the graph, or in this case, the green line. So the domain will be all real numbers. The range now. The range is talking about the y value. So now I look at my y coordinates. So I'm just going to make this horizontal, and I'm going to start at the very top. So top of my y axis, and I go across. It's touching the green. Still touching the green, still touching the green, still touching the green, until I hit the yellow asymptote line. Now I don't see any green there. That means once it hits the asymptote, it's no longer valid. So my range is going to be everything above the asymptote. And so if the asymptote is at 0, my asymptote, or my range is going to be greater than 0. Now in a word problem, it could vary because maybe it could be any real number. But for the most part, when you're dealing with a basic exponential function, the domain is always going to be all real and the range is going to be greater than 0. Unless if the asymptote changes, then it's always wherever the asymptote is, and it could either be above that line or below that line. Other key features I want you to focus in on is the y-intercept. The y-intercept, where does it cross the y-axis? So now if I take my ruler and go all the way down until it hits the y-axis, which is right here, and we said that that was when x is 0, y was 2. So it crosses the y-axis at 2. The other one is the asymptote. The asymptote is just an equation. So the asymptote line is, or the asymptote is going to be an equation of a line, which would be y equals 0, because that's what the line, my asymptote line is. So it crosses the x or the y-axis at 0, which is the x-axis here. Okay, and the last thing is the end behavior. And the end behavior for a decay like this one, so this one's a decay, as x increases. So when I go to the right, my green line approaches 0. So that means my y approaches 0. And as x decreases, so when I go to the left, you can see that the arrow is pointing upward. That means my y increases. Now, if this was a growth, then my two statements would be switched around. But that is a quick review on how you can graph an exponential and then identify 5 main key features.